Okay, 9.72 of Sonntag. We have a 0.2 meter cube vessel which is filled with water. So the vessel is initially empty. This is an empty vessel. It is filled with water from a line which is operating at, this is line which is operating at 500 kilopascal and 200 degrees Celsius. So the valve is opened and there is no more flow, which means that the internal so initially everything is zero. So initially everything is zero. The second state, because there is no flow, it means that the internal pressure has reached 500 kilopascal. So assume that the process is adiabatic. So find the final mass, final temperature and SGN. Okay, so using the conservation of mass, m2 minus m1 equal to mi minus me. So me is 0, there is no mass exiting the system, there is no initial mass, therefore m2 equal to mi. It is from the conservation of mass. Also m2 u2 minus m1 u1 equal to mi hi minus me he minus w. So there is no work extraction from the process, and there was no initial mass and there is no exiting mass. So m2 u2 equal to mi hi. If I use equation 1, then u2 equal to hi. Okay. So using the conservation of, so the entropy, m2 s2 equal to mi si plus sgen. Therefore simply sgen is equal to m2 s2 minus mi si. Okay, let's see how we can solve this problem. So this is 9.72. So state at the inlet, Pi equal to 500 kilopascal, Ti equal to 200 degrees Celsius. Okay. So U2 equal to Hi, where Hi equal to enthalpy of steam, T equal to Ti, P equal to Pi. So this should give me what U2 is. Also I know what P2 is, it is equal to 500 kilopascal. Now using this I should be able to find what the specific volume is. Okay, using the specific volume and the total volume equal to 0.2, so the mass equal to vol divided by the specific volume. Okay, so the mass, so it is grabbing hold of Pi as pi apparently. So the mass, final mass is equal to 0.3611. This is basically m2. Okay, so we know what the final mass is. What is the final temperature? That is very easy. T2 is equal to temperature of steam at P equal to P2, U equal to U2. That's easy. What is the total entropy generation? So the entropy generation as gen, as we found out in this equation, is equal to m2 multiplied by s2 minus si, because here m2 and mi are equal. So we simply need to find si equal to entropy of steam at T equal to Ti, T equal to Pi, and similarly S2 equal to entropy of steam at P equal to P2, U equal to U2. Using this, we find out that the total entropy generation is equal to 0.1864 kilojoule per kg, kilojoule per Kelvin, because here we have multiplied with the mass. Okay. So it's a very simple problem which elucidates the use of the transient equation. If you do not remember how we arrived at the equations, we simply used the general form of the balance of entropy of the control volume. Then we integrated everything in time by assuming that the properties are homogeneous, the inlet and the exit conditions do not change in time, the heat transfer does not change in time. Okay, because the process was adiabatic, the heat transfer does not come into the picture. It's a very simple problem otherwise. Okay, so this. Okay.